Hello, and welcome back to Mammalian Anatomy at Keuka College. In this video, we're going to continue our conversation about Chapter 16, the special senses. And here we will focus on physiology of vision. So in our previous videos, we looked at the anatomy of the eye and defined the function of each component of the eye. We also looked at the eye as an optical device and studied how the lenses, aqueous humor and the cornea has the capability of refracting light so the image can be projected onto the retina correctly. And here we're just going to kind of bring it all together and kind of go through vision kind of step by step. I did write out step by step for you so you can have this available to help you study. So I will give you a moment to be able to write down this information or be able to pause for 1 through 5. And here is 6 through 10. But instead of focusing on text, I would like to kind of illustrate the physiology of vision on a diagram. So we've been looking at this diagram as we've been studying the anatomy of the eye. And so let's kind of go through the steps of physiology of vision together. So here's my cursor. So essentially what will happen is light will be emitted from a light source, and that light will be reflected off of an object and then directed towards our eyes. As the light enters our eyes, it will first pass through the cornea and the aqueous humor. And because of the significant curvature of the cornea will refract or bend the light as it is entering the eye. The iris will control how much light will enter the eye, and the iris can dilate and contract to control that light. It also can help make sure that parallel rays of light are entering the eye, especially when we are looking at a nearby object. That light will then go to the lens, and the lens will upbend the light as well. The amount of or the degree in which the light bends will depend on the shape of the lens. The lens can flatten and relax to accommodate for different amounts of refraction that are necessary. The light will then travel through the viscous humor, and it will hit the retina, mainly near the macula lutea and the fovea centralis. Here there is the retina, and in the retina we're going to have photoreceptors that are capable of detecting that light. So let's zoom in on the retina a little bit more and look at the structures that are involved with continuing this process of vision. So we said that light actually came in this way, and it would actually hit the photoreceptors, which are close to the posterior part of the retina. And the photoreceptors are going to detect that light and convert that light into an action potential that can be carried through neurons in the central nervous system. So the photoreceptors will convert that stimulus of light into an action potential, and the photoreceptors will communicate with the bipolar cells. The bipolar cells will then communicate with the ganglion cells, and the axons of the ganglion cells will actually become the optic nerve that will carry the visual sensory information to the central nervous system, where it will be processed. Do remember and do take a note that there is a lot of neural integration that occurs within the retina. We have convergent neural integration or convergent circuits between the photoreceptors, the bipolar cells, and the ganglia. And we also have interneurons that will help in processing visual information, such as the endocrine cells and the horizontal cells. So visual information is processed by the retina, and from there, the optic nerve will send the visual information to higher levels of the brain for more processing to occur. So that kind of briefly summarizes the physiology of vision. Sorry, I'm getting tongue-tied. Physiology of vision. This could be a possible essay option, so I just want you to know the steps that are involved. Thank you for listening to this video and have a wonderful day. Goodbye. And be good to yourselves.